Let's start with a question. Which of these volcanoes is tallest? Now, of course, being a smart and switched-on geography teacher, you will know that that question, as it's framed at the moment, isn't quite possible to answer because I haven't given anything by way of scale. And yet, this set of images, I think, probably represents one of those common misconceptions that a number of students can pick up whenever you're looking at the difference between sealed volcanoes and composite volcanoes. Because one of the differences that, of course, you'll stress to your pupils is the difference in the form or the shape. The sealed volcano at the top being characterized by very gently sloping sides, whereas the composite volcanoes are much more cone-shaped, much more like your classic volcano that you would draw. And unfortunately, sometimes the pupils think that because the shape of the composite volcanoes is much more pointy, they must be taller, whenever we will know that's not exactly always the case, not necessarily so. And particularly if you know which of these three volcanoes are in the world, you will know that it's definitely not as simple as that. The top one, I'm sure you've got that. That's Mauna Loa, the most famous seal volcano in the world. Bottom left, in the Cascade regions overlooking Seattle, it's Mount Rainier. And down in the bottom right, we have Pinatubo. Now, you may well know the different heights of those volcanoes. You may know which one is the tallest just by your own general knowledge. But the students, as I say, can be very much confused sometimes by the shape. And it doesn't help sometimes whenever you get diagrams like this that are absolutely not the scale, that show some of the characteristics of them, but really don't give the pupils any kind of sense of which is taller and which would not be. So what I'm going to do is to show you a GIS-based task that you can set up easily that will allow your students to find that out for themselves and explore it. I'm going to show you how to set this up right from scratch, so if you've never used ArcGIS before, you'll get a good indication as to how to do this and how simple and straightforward it is. So once you've gone in, logged in, you will go to your map, which will open up and create a new map for you. And then we're going to add on a couple of layers, a couple of content there. So you go add and search for layers. And the first thing that I want to add in, first thing I'll need to do is to change it where it's searching into ArcGIS Online. This is where anybody across the world who has set up a map and has shared it, this is where it will be found. So we're going to look for world volcanoes. There we go. And just search for that, and I'm going to just use this one here, set up by Esri, and just add that on, zoom out a little bit, and there are world volcanoes. Now, what I want to do is to go in here to the content tab, and I'm going to change how that displays a little bit because it's showing the location only. So I want to show the type of volcano. And what it's showing me is the different types of volcanoes that are around the world. So there we go. That's that one done. Then I want to put on something for plate margins. Again, search for layers, the ArcGIS, and plate boundaries. And there we go. We'll add that one on. And it appears, and I'm going to go back into the content tab, and one of the things I want to do for that one, again, it's showing location only. I want to turn on the type, and what it will do is show us the different types. Click done, and there's the legend, different types of volcanoes, different types of plate boundaries. Okay, so what I want then my pupils to do is to go in and to survey a few of these. So let's change the base map here to imagery, and we want to go to Rainier. So you just search for it in the search bar there. I'll zoom in a little bit closer, and there it is. Now, if we're wanting our students to get that location much more quickly, it's very simple. It's just go bookmarks, add bookmark here, and Mount Rainier. There we go. Hit enter and it's added. Now, how are they going to get the information that you want them to collect about the shape of this? Well, if you click on the dot, first of all, that little dot contains the information about the volcano. And you can see here that the volcano is 4,392 meters high in elevation. They can collect that data. Just set up a table for them and they can collect it. We can also get a sense of the width of this volcano by using the measure tool, and we see that the volcano is about 13 kilometers wide. And lo and behold, you have got the width and you have got the height. Now, what about another one? What about Mauna Loa? Let's go there. And we can head down here. There we go, Mauna Loa. And again, we can add the bookmark. And we can add in the bookmark here, Mauna Loa. There we go. And very simple, there's the height, 4,170 meters. And zoom out just a little bit more, we can get the diameter of the volcano here. Something in the region of 90 kilometers, something like that. And we can go around a series of these. You can set up as many of them as you like. You can set them up as bookmarks again. Just very simple. Add bookmark, Pinatubo. There you go. And in we go to get, again, the information you need. The dot gives you the height. And then my bandwidth is definitely playing up a wee bit here. And then you can measure the diameter of it there, about 14 kilometers, something like that. And what they can easily do then is to go and collect a series of pieces of information about the height and the diameter of a series of shield and composite volcanoes. Okay, let's see what my students got up to whenever I got them to do that. Here's one of my students' slides where she collected together information. You can see the kinds of things that I got them to collect here and the different places where we went around the world. Now, what this will clearly show is heights and diameter. There you are. But again, I wanted them to really get a sense of how these shapes and heights and diameters relate to each other. So I got them to graph it like so. And as we started to construct these graphs, we got a very, very interesting pattern beginning to emerge, because we started with Mount Rainier, and you can see that the height of it here, it's the tallest one, slightly taller than Mauna Loa, at least if you measure it from the height from sea level. But you can absolutely see that this is much, much narrower in shape compared to Mauna Loa, much, much wider. And once you throw in a few others, there's Mount St. Helens, there is Pinatubo. And you can actually see here the shapes of these volcanoes as you put them on, and you can see the width and the height. And it was that moment when I got the students to draw these graphs, whenever it really clicked with them, that it's to do with the shape of the volcano, and that the shield volcanoes can be much, much taller than the composite volcanoes. It depends on the height and it depends on the width. So back to our initial question, which of these three was tallest? Well, Mount Rainier, followed by Mauna Loa, with the itty bitty Pinatubo in comparison coming in third place. But you can see now how going around the world and collecting this information using ArcGIS, plotting it into a table then onto a graph like this, can really bring this to life for them, and they can definitely see the shapes and the forms and the heights of these two types of volcanoes.